Okay, so let's take a look here at the green review. All right, I want to review the two that we've done already. We'll go over the third free response question. Okay, I'll give you a little more time here in class to go over the rest of this green one here because we have, I think, gone over some of them, but not all the questions or whatever. Anyway, I want to give you guys a chance to finish up the green one for sure. Okay, we'll start into the blue one today. We'll finish the blue one tomorrow, and then that should hopefully prepare us then for that benchmark on now Wednesday. Wednesday now. Okay, Wednesday is the benchmark. All right, so let's take a look here. Remember that the benchmark, sorry, one other thing. The benchmark will be 15 multiple choice questions. So very similar in form, like the almost identical format to what you see right here. I mean, it is the identical format, right? 15 multiple choice questions, all right? And then there'll be 3 free responses, okay? Multiple choice is basically worth half of the test, and the free response questions are also the other half, all right, of the test. So, you know, that adds up there, all right? So even though there's 3 free response questions, right, there's parts and lots of, you know, multiple points and stuff like that. So these 3 questions, 16, 17, and 18, they add up for half the test, and then the 15, 1 through 15, add up to half the test, okay? Remember that multiple choice, there's no partial credit, right? So it's either right or wrong, okay? So it's a point or it's 0 points, right, for those multiple choice. So it's super important that you get those down, right? Mr. Woodmeyer cannot award partial credit for those questions. Here, there's, you know, a possibility for partial credit, but just make sure that you do, you know, take advantage of this information that you're being given here, you know. Really make sure you get down those multiple choice because they hurt if you get those wrong, right? You can get partial credit here, so it's not as bad, but you still want to, you know, at least put the effort in and stuff like that. So, okay. That being said, all right, let's take another look here at these. This first question here, number 16. We've already done it once, but we'll talk through it again here. So Marlene bought a tie-dye kit for $50. She plans to buy T-shirts for $5 each, tie-dye them, and then sell them. All right. Model the situation with a rational function. Remember, rational functions, what makes a function rational is that it's going to be like a fraction, okay? This particular rational function, okay, gives the average cost, C of T, okay, of a tie-dye T-shirt, T, when the cost of the kit is included in the calculation, okay? So what was the cost of the kit again? Well, it was $50, right? Okay, so we have the $50. But then it also, their T-shirts, each T-shirt costs $5 to actually just buy the plain T-shirt and then to tie-dye, okay? So 50 plus 5T gives you the total cost, okay? 50 plus 5T gives you the total cost. But we want the average cost. How do you normally find the average of something? You take the total and you divide by the number of items that you added up, right? So in this case, we would divide by T, okay, the number of T-shirts, okay? So total cost divided by number of T-shirts there, okay? That gives you the average cost. Let me put that up here maybe too, it can't hurt. So average cost is total cost divided by number of items. Okay, if you want that there, just as a general kind of like guideline there. Average cost is total cost divided by number of items. Okay, I can almost guarantee that you'll see one just like this on your blue paper. Okay, very similar, and I can almost therefore guarantee you'll see one very similar to this on your benchmark as well. Okay, so you really want to make sure you have that understanding of average cost out. In fact, let me just peek at the blue one here and just see. I feel like. Yeah, so in number 16, on the blue paper, it's about piano lessons, but it still is asking for the average cost. So that will be there as well. Okay, anywho, letter B says then, graph the function on the coordinate plane below and label the axes, right? So be sure to identify asymptotes with dashed lines. Now, folks, when it says label the axes, that means there's points involved, right? You should always do it anyway, but for a word problem and stuff. But in this case, it says it. There's going to be points involved with that. So make sure, please, 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 that you label those axes correctly. Number of shirts on the x-axis, and then average cost, dollars per shirt, right? Because the y value is average cost there. So that's average cost, dollars per shirt. Okay? Now, how can we actually like graph this thing? What can we use to help us graph this? What can we use to help us graph this? No ideas? Everyone's tuned me out in the first 15 minutes of class already? Gagarin calculator, that's right. Okay, so we're going to type in our function here, 50 plus 5x divided by x. Okay, and we go to our graph. Ooh. Okay, let me try zoom 6 here and see if that makes it better. Zoom 6. Okay, there we go. Okay, I can see part of it down here, but I'm not really interested in this part because that's talking about like a negative number of t-shirts and a negative average cost, which does not make sense in context. So I need to start. Now I know that the tie-dye kit costs $50, so I'm going to try and go up to the y value, y max of 50, and let's see if that helps at all. So we'll see there. Okay, so that's a little bit better. Okay, at least gives me like somewhat of a curve there. I can also look at my axes here, folks, right? I mean, it tells us the y-axis here is counting up to 55. The x-axis is counting over to 55. So maybe we should also change my window here. I'll just make my x max 55 and my y max 55. Just using the kind of cheating there. Well, not cheating, but just using the information they gave us. And there's our curve. Okay? All right. You can see here that it looks like we're kind of flattening out. And it looks like we might not get to the x-axis. And in fact, we don't. Okay? We have a horizontal asymptote at 5, okay, and then we also have a vertical asymptote at 0, okay. Now, if you look here, right, that's kind of clued in the function here, right? What t value would make us undefined here? What number, if I plugged it in for t, would give us a problem in our function here? What t value would give us a problem here in this function? Not 5, 0, right? Why would 0 give us a problem here? Well, it wouldn't equal 0. When you divide by 0, that's undefined, right? And so that's why we have a vertical asymptote at x equals 0, or maybe you could say t equals 0 there. I mean, anyway, yeah. At this, we have a vertical asymptote there. And again, why do we need to say that? Why do we need to label that? Identify asymptotes. So you have to identify that there's an asymptote here by using a dashed line, okay? If you don't include this in your graph, you may lose points. Please don't lose points for silly things like that, okay? Do what the directions tell you to do. Same thing with the horizontal asymptote here, right? Horizontal asymptote, well, if you see the degree of the top is 1, the degree of the bottom is 1, right? The highest power is 1 and 1, and so it's the ratio of the lead coefficients, 5 over 1. There's your horizontal asymptote. Another way to see that, right, is to just kind of like trace your function here, and you'll see that we keep going down, 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 down in y value, but it's kind of flattening out. You can see we're just going to get closer and closer to 5, but we're never going to actually get to 5 there. Okay, so you can use that to help you too. All right, let me fix my window here. Okay, so anyway, there's the graph. All right, and then lastly here, determine the minimum number of t-shirts that brings the average cost below $8. Okay, solve graphically above or show your work algebraically below. Okay, so we want to know when the average cost is going to be $8. Well, we can just graph the average cost of $8. We'll just put in an 8 here. Okay, graph an 8. And you see right here is where they cross. So second trace, intersect. There you go. So how many t-shirts, after how many t-shirts that will bring the average cost to $8? How many t-shirts will bring us to an average cost of $8? Will 16 be enough t-shirts? No. How many t-shirts do we need to make? We'll have to make 17. We'll have to make 17 to round up there, right? Round that up. You can also go to your table and check it out there too. You can see, you know, okay, here it's still above $8, still above $8, and then right there at 16 it's 8.125, at 17 it's 7.942. So after making 17 or more t-shirts, the average cost would be below $8. Okay. So, questions on any of that? And again, there's the answer. 17 t-shirts brings the price to $7.94. 16 t-shirts is only $8.13. Okay. If you just use this on your graphing calculator, that's fine too. It says solve graphically above. That's going to be hard to see, like where it intersects. You can draw in the 8 if you want to. I mean, here would be like the 8 line. Let's see, it's 10, 9, 8. There's like the 8 line right there, but it's hard to see like where exactly that intersects, right? So instead, I would say, you know, use your graphing calculator and graph it. All right, so that's number 16. You'll see one just like this in the blue paper. Okay, so you can refer back to this one. Okay, I think it's even number 16 in the blue paper too. So. We didn't do 17 yet. We'll hold off on that. Let's review 18, and then we'll go back to 17. Okay? 18, an ornithologist, which is just somebody that studies birds, is studying the population of migratory birds in the Serengeti. Right? The population of species 1, P sub 1, is decaying by 25%. Don't get thrown off here by that little sub 1. That's just there to denote that this population is the first one. And then we have P sub 2, just to kind of differentiate between these two P variables there, right? P sub 1 is for the first population, P sub 2 is for the second population. Okay, anyway. P sub 1 is decaying by 25%. Now, the only context that we've talked about growth or decay is what kind of functions? What kind of functions have a growth or decay with them? Exponential, right? So these are only exponential functions we're talking about here, right? That kind of clues you in. That's another thing you kind of help organize your understanding of this review or this test, the benchmark by, right? There's only 3 units that we've really covered, right? Up since the last benchmark, right? We first started with exponents and rational functions, or sorry, exponents and rational exponents. Rational exponents, like square roots and cube roots, that kind of unit, right, was 1. Then we had rational functions, where we had like fractions in our functions with fractions in them and stuff like that. And then we finally had, for our third unit, we had the exponential equations and logarithms and stuff like that, okay? So this is from that most recent unit that we did. All right, anyway. The population growth of species 2, P sub 2, can be modeled by the function P sub 2 equals 70 times 1.2 to the t, where t is measured in years. So remember here, if we're talking about exponential growth or decay, our key equation is y equals a times b to the x. What does a represent for these exponential growth or decay equations? A represents the starting or initial amount, yes. Okay, so I'll put that right there, initial amount. And what does b represent in these equations? What's that? Yeah, percent growth or percent decay. Yeah, so I want to be a little bit careful here, though, because it's not the straight up percent, though, right? It's not just straight up, you put the percent in there. So this is the growth or decay factor. Okay? We actually refer to it as the growth or decay factor. For growth, b is equal to 1 plus r, where r is the percent growth. Decay, that would be b equals 1. Well, instead of 1 plus r, we would put what? 1 what? Minus r, and that would be for the percent decay. Okay? So if you look here, for example, at this population right here, population 2, okay, what's the b value in population 2? 1.2, which means by what percent are they growing every year? 20%. Yes, very good, Mike. Yes, because we add that 0.2 to the 1, right? 1 plus 0.2 gives us 1.2. And so 0.2 or 20% is what they're growing by every year. Okay? So write the function for the first species, because we didn't get a function. We just have it's decaying by 25%, started at 5,000 birds. And so A is going to be 5,000. Okay? And then 0.75, because it's decay, right, we're going to do 1 minus that 25% there. So 1 minus 0.25 gives us the 0.75 right there. Okay? Okay, just like that. 1 minus 0.25 equals 0.75. Okay? So there's your equation. Okay? Part B. What is the population of this first species, P sub 1, at 4 years? So we don't know what the population is. That means we're going to find P after 4 years. So 4 would go in for T. Okay, so plug 4 in for T, and then you just literally just type this in your calculator, right? 5,000 parentheses 0.75 to the 4, and you get 1,582 birds. Okay, easy peasy. Letter C, during what year will the population of the second species be 560 birds? So now we are during what year? That means T equals what, right? We're trying to solve for T here. Will the population of the second species be 560? So this is our P sub 2 value right there, 560. So you're going to put 560 in for P sub 2, and you're going to solve this equation. Okay. Now, how can we solve? Well, we could graph. We could also use logarithms. I showed you how to do it with a logarithm here. Divide both sides by 70. Use log base 1.2 of both sides. And so you'll have T is equal to approximately 11.4. When you type in your calculator. So in other words, in the 11th year, it'll reach 560 birds. Okay. You also, I guess, could have used your table in your calculator too. So in other words, you could use a graph and then just use the intersection point, right? Find the x value for the intersection point there. You could also use your table. That wouldn't be too hard to do, I don't think. Anyway, and then finally, letter D. During what year will the two populations be equal? That's easy, right? You set them equal, okay? And then I use my graphing calculator. Graph and find intersection point. The populations will be equal in year 9, okay? So there's our answer right there. That's where the two population curves intersect. Okay? And I don't, does anyone need me to run through about how to find the intersection point or anything like that on the calculator? You guys are good with that? Gio, you want to see it again? Yes. Can you just, if you can wait, we're going to go over the next question. I don't want you to miss that. If you can hold it, and then you can go right as soon as we're done, okay? Because I just want to make sure we get number 17, the last free response question here. Okay. So, 17, the approximate period t of a pendulum is given in seconds by the formula t equals 0.6 times the square root of L, where L is the length in inches. Okay, so first of all, do you guys even know what a pendulum is? What is a pendulum? Yeah, Gio, you got the right idea. It's like anything that really is like swinging from like a length, like a weight that swings from like a length of rope. So if you think about like a clock, you know, like the really like tall clocks are called grandfather clocks, and they have this like, you know, like the tick-tock, like those things that swing down the bottom. That's like a pendulum, okay? Or just any, you know, gosh, I don't know. Yeah, anyway, that'd be a good idea of a pendulum right there at least. So it swings, right? And it kind of like goes back and forth in a regular kind of motion. So it has this repetition or a period, how often it repeats itself, okay? And so the number of seconds it takes to repeat itself is dependent on how long the string is, right? The longer the string, the longer it takes to repeat itself because it has longer to swing and stuff like that. Anyway, we're going to graph this. Be sure to label the axes. So what should our x-axis be labeled, you think, here? What's like our x variable in this equation up here? Time is actually not the x variable here. Yeah, length is, because it's given in terms of length. See, all this stuff over here, the L is, which I know, Nick, that is different than what we're normally used to seeing. Okay, but it's actually length in inches, and time is dependent on the length of the string. Okay, so then what's the y value got to be here, or y variable? What's the label for the y variable? And that is time. Okay, and that'll be time in seconds. Okay, so how long it takes to repeat itself is dependent on the length of the string, okay? So, now, let's graph this thing, right? So we'll type into our graphing calculator. Okay, so I'm going to type in 0.6, and then how do I do a square root again? What do I press? Second x squared, gives me the square root there, and I'll put in then L, but it's x for us because we have to use the x command there. And there it is. That's the curve. So we're just going to graph it. Now, I can see here on my labels, right, that they already gave us that it's counting from 0 to 9 on the y-axis and 0 to 90 on the x-axis. So I'm going to go ahead and adjust my window using that information. So my x min is 0, and my x max was 90. Again, the farthest right we go is 90 here. And then the y min, I'm going to adjust that to be 0, and my y max to be 9. Okay? If you want to even more closely resemble this graph, you can see that we're counting by tens down here, and if you really wanted to, you could change your x scale to, instead of counting by ones, you could change it to count by tens if you wanted to. That's your choice. I'm going to leave it counting by ones, though. All right, and there's our graph. All right? Now, how can I take this information here and put it here? What do I need to look at now? Okay, I can look at some points, which will be in the table. So second graph, go to the table here. I'll go back to the very start. Okay, so at 0, we're at 0. Well, that's easy enough. Okay, the next point's going to come at 10. So I have to scroll down to 10 here. 1.8974. So 10 is 1.89. So that's pretty much 1.9. So it's pretty close to 2 there. We'll say something like that. Okay, and then I'll scroll down to 20. Okay, 2.68, 2.7 we'll say there. So at 20 we're at 2.7. Okay, something like that. Okay, it's kind of a lot of scrolling here. Here are some options you could have if you don't want to have to scroll through all these numbers. I mean, it's not that bad, I guess, but if you want to do it a little bit faster, you have a couple options. Option 1, you can go to second window, okay, and you can change how your table counts by. So I'll start at 0 still. I'll have my table count by tens instead, and then you can see it just counts by all the tens, right? Just like that. So that makes it a little bit easier to do, okay? Or if you don't want to change your table, your delta table there, you want to just change it, keep it 1. You can also change your independent variable from auto to ask, and in that case, when you go to your table, it's blank, and you can type in whatever x values you want. So 0, 10, 20, 30, 40, 50, 60, 70, 80. Oh, that's right. It doesn't go all the way down. So I'll go up to 60 there. So let's see here. 30 should be 3.3, we'll say. 40 will be 3.8. 50 is 4.2. And then 60, I get 4.6. Okay? And I'm going to go ahead. I don't need that many more points. I think we get the rough idea here about what it looks like, something like that. Okay? So there's the curve. All right. I'm going to change my table, though, back to the normal viewing window there, or the normal thing. So I'll change it again. Second window, I'll change it from automatic, or from ask to automatic there, so that way I can just have it automatically fill in. Okay. What is the period for the pendulum if the length of the pendulum is 36 inches? Okay, so 36 inches, that is a length, so that can go in for T or for L? L, right? That is a length. So that equals L. So we'll do T, the time, right? What is the period? So that's the time. Equals what, right? T is equal to 0.6 times the square root of 36. Okay, now this one's actually not that bad because what is the square root of 36? It's 6, right? So we're just going to do 0.6 times 6, which is going to be 3.6 when you do it there. And 3.6, what should our units be here? 3.6 is a time, right? So seconds is right. Okay, just like that. Letter C, if the period for the pendulum is 3 seconds, so that is now a time, what is the length, okay, of the pendulum? Label your answer. So now we're going to put 3 in for T, so it'll be 3 equals 0.6 times the square root of L, okay, and I have to solve this equation. So what should I do here to solve for L? What can I do to both sides to start solving for L? Divide both sides by 0.6, okay, 3 divided by 0.6 is 5, okay, and then now what do I do to both sides? Get the L by itself. Not square root. There is a square root. How do we cancel out a square root? Square both sides. Very good. And that maybe was what you meant to say, but yeah. Just want to make sure for everyone else that was listening there. And then 5 squared, well, that's easy. It's just 25. And this will be 25 inches. Okay, and so there's our length. Okay. How similar is that to the, I mean, we're almost done. I'll do this last one here in just a second, but I just want to make a comment here. I mean, how similar is that to the question that we just were talking about, right? I mean, so let's see here. We've, for this one right here, well, okay, it's kind of similar. Never mind. It's like related to this one too. I mean, we found the population given a number of years, but then we were given a population and tried to find the number of years and stuff like that. So these questions are all very similar, just with, the difference in functions is really what we're doing there. All right, last thing here, what is the average rate of change of the function between 16 inches and 49 inches? Okay, so average rate of change means we're finding the average rate of change. What do we use? Yes, the slope. Thank you. Slope, slope, slope. So that is going to be our average rate of change. Okay, is the slope, which is equal to y2 minus y1 over x2 minus x1. Okay? Now, are we given x and y coordinates here? Are we given x and y coordinates in this information here? We're not, right? What are 16 and 49? Are they like x coordinates or are they like y coordinates? They're inches, right? So are they like x coordinates or y coordinates here? They're like x's, right? Okay, so we have the point 16, but we don't have its y coordinate. We have the point 49, but we do not have its y coordinate. How can we come up with their y coordinates? What can we do? What's that? We have the x coordinates. What can we do to find their matching y coordinates here? Or we have the L coordinates. We can use the graph. We could also plug them just back into the function up here if you wanted to. Okay, plug 16 in for L, plug 49 in for L there too. Okay, and then get the matching y values. Let's use I'm going to use the table actually, I think. So I'll just scroll down. Okay, 16 is 2.4. And I got to scroll down. Actually, can I just? No, well, let me do that. All right, I'll just scroll down to 49. 4.2 as well. Okay, that's good. 2.4 or 4.2. How interesting. Okay, we're going to take these 2 points now, and we're going to put them in the slope formula. So 4.2 minus 2.4 over 49 minus 16. Okay? 2.1 in the numerator. I should know this. 33 in the denominator. Okay? And it says round to the nearest hundredth. So I'm going to go ahead and just divide those two then. So I get 0.06. Okay? And so there's my answer. Now let's see here. The y coordinates have a label of seconds. And then the x coordinates have a label of inches. Okay. It doesn't say to describe the meaning in the context of the problem here, but the meaning would be something like this, right? From time, or from 16 to 49 inches, right, the average rate of change in time is 0.06 seconds for every additional inch, okay? So between 16 and 49 inches of length of string, okay, the average rate of change is 0.06 additional seconds every 1 inch that you add, okay? So there's that. All right. Questions on any of this? Yes. Now you can go, Gio. Thank you for waiting. All right. So then if you don't mind, if you would please go ahead and continue your work here on the green packet. All right. If you finish looking at all those multiple choice and you're feeling good about them, then feel free to move on to the blue one there. All right. I'm going to give you guys good 20, 25, maybe even 30 minutes here. We'll see to continue working on this. We'll stop at that point, and then I'll go through all the answers here from multiple choice, okay, for the green packet. Okay, see if you guys have any additional questions. Of course, you can feel free to ask me questions, in that time too. Okay, but I'll give you about 25 minutes or so to work on this some more, and then we'll go over the green packets and multiple choice. Okay, if you're all done the green one, move on to the blue. If you're all done the green and the blue, I can find you some more review if you really want. Okay, if you'd like something else to look at, because it can't hurt, right? So, yeah, let's get to it here, folks. And I'll stop the video too.